Good morning. I hope you're doing well. I'm doing well. Cognitively, I'm doing well. Physically, my body did not enjoy this week one bit. I spent so much time just soldering stuff and unsoldering stuff when the soldering was done incorrectly. And yeah, my God, it's so tedious. But thankfully, as far as I can tell, it's all done and it's all working. And yeah, it's good. I'm very, very keen to show you what I've put together. It is like, ultimately it's just like one part of what needs to be done for Ball Butler to work, but it's a big part that hopefully should be functional for a long time to come. And yeah, I'm very glad that this is out of the way and working from as far as I can tell. I haven't had enough time to test every little component of this, but everything that I have tested has worked really well. Yes, my emoji keyboard is still not working and it's driving me mad. But yeah, so I don't think there's a single emoji in this PowerPoint. I think this is probably the first PowerPoint with no emojis in it, which is very saddening, but it is what it is. And we have no fun tangential thought this week because I've been too busy on other stuff. And yes, the circuit board is done. So this here, I'm going to try to not touch any of the main components because I don't want to zap anything, but this is my circuit board now, and well, the circuit board for Ball Butler, and I think it looks quite neat. I've got some close-up pictures here to show. I should have moved them all over a bit. Bugger. Oh well. Yeah, I'll hide me for a sec and then bring me back. And yeah, I feel like this is fairly neat. So I've got a lot of mixed feelings about this because I want this to be kind of small and compact so that way when I put it into the base, it doesn't take up too much space and I have a bit more freedom with where I can actually position it. But the smaller I make this, the harder it is to wire everything together in the correct way so that it's all linked up the way that it needs to be linked up. And I also only have I've only got a couple of different types of this, like perf board or Vero board, whatever you call it, the like brown board on the back that you actually solder everything onto. And I figured that I only have a handful of components here. There's just like a couple ports to go in and out. There's the Teensy, 2 CAN chips, and a buck converter. And actually, I'll show you first before I go into the photos in too much more detail. I'll show you this CAD. So as always, there's a link in the description for the latest version of Ball Butler. And this circuit board is in the stage 1 tab, if you want to check it out. And while I was putting this CAD together, I was kind of thinking like, this is definitely the most effort I've gone to for this sort of like mock-up CAD, because realistically for this CAD, all that I really needed is the profile of the board, like the brown board itself. And that's kind of it, because I will at some point, I haven't actually done this yet, but at some point I will need to 3D print a little mount thing to actually hold this, and then that will attach this circuit board onto the base so it's like locked down and won't shake around if I move the robot around. So I only really need the profile. And I got a little bit, at the time it felt like I was getting a little bit carried away with doing all this labeling of everything, but I actually don't regret it at all. And I am very glad that I went through and labeled all of these components the way that I did, because now, if in the future I want to diagnose anything to do with the actual physical board, nothing on this board is labeled. Like it's like the 2 blue chips are like the CAN transceivers, but it's very not clear, and you'll see what I mean in a bit more detail in a sec. It's very not clear which CAN transceiver is which. And like these 3 white JST connectors down here, it's like I know right now what they are, but later down the line, I might kind of forget exactly which way each one is wired to each other one. So I think I'm glad that I did this labeling, and I'm actually intending on having the 3D printed mount that this sits in. I'm hoping to put some text on that 3D printed part so that way I can see from above very easily on the physical thing. It's like 12 volts in this way, like this one's positive, this one's negative. CAN in this way, this one's high, this one's low. So hopefully this labeling will make it a little bit easier to do that. And yeah, so this is like what each component is. Of course it's sideways, but whatever. Yeah, so this is what it looks like with all the components on, and it's all fairly neat. Like there's a couple little straggling cables sticking out the corner here, but it's fairly neat. But then when we take the components off, we realize what's hiding underneath. And this is a mess. It is very hard to see what's connected to what. And it really frustrates me because at the start, when I started working on this, I was like, oh, this is going to be so good. I'm going to make it all really neat. It's going to be like those like YouTube short videos that you see where like everything's wired perfectly and it's like so beautiful. I was so keen to get it that way. And then I put about 2 cables in and realized, fuck that, that's going to take way too long. And I am not that patient. So, well, and I don't need it to be that neat. And I also don't really have the space to make it that neat. Like there are just like too many cables going through here. Why am I on a razor? Too many cables going through here for it to be that neat. I think if I wanted to make it really neat, I would have to make it a lot larger. Yeah, so I don't know. There's a couple little things that I want to just. Thank you, Rodiger. Yeah, it's definitely not the messiest thing ever, and it took so goddamn long to measure all the cables out, bend them all the right length. But yeah, I think it could definitely be neater. And there's a couple of things that I wanted to show off that I thought were kind of, I don't know, one thing that I think is kind of cool, and one thing that was supposed to be cool, but very, very, very closely became very annoying. The cool thing is this section over here where I've got these 4 cables running up from this plug will go to the brushed DC motor, and just for full, I don't know, so you're fully aware of exactly what's going on here, I actually only need 3 pins to control the brushed DC driver. I only need 2 pins to set the direction of which way the motor should spin, and then a PWM pin, which I've checked the datasheet for this time, and I've made sure it's actually on a PWM pin, and that just sets like the speed of the motor. But you'll notice that I have 4 pins here. And originally I didn't actually have 4 there. I only had 3 because I only need 3. But then as I went through to the next step, which is to set up the cabling for all of this to actually connect things together, I realized that I already have a bunch of different types of shielded cables, and it would be kind of stupid to not use shielded cables here, given that I have the cables. So I made a shielded cable connector for the brush DC motor, and you'll notice that on this side this is a 4-pin connector, and that will connect to this chip that I'm just showing here. And then on the other side there's only a 3-pin connector, and that will connect to the driver itself. And where is the 4th pin, you may ask? Well, that's the shield that runs through the outside of this cable, and that shield is connected to the ground, like that's connected to the black cable in here, which then goes to this black cable here, which then connects to the system ground. So that way any stray electromagnetic interference that comes along here will get picked up by the shield, it will get taken by the shield into the ground and then disappear, hopefully. Yeah, this took me a little while to learn some time ago, is like how to do the shielding properly, and as far as I can tell, this is the best way to do it, where you have only one end is connected to the shield, and that shield is connected to ground only on that end. If you don't connect the shield to anything and it's just there floating, as far as I can tell, it does help a little bit with shielding like EMI, but it doesn't get rid of nearly as much as if you ground that shield to ground. And then alternatively, if you ground the shield on both ends, then you risk having ground loops where you can get like, you get like a full loop and current can flow through, and I don't know, ground loops confuse me a little bit, but it's not a good thing to have. So you only want to connect it to one end, and you want to have it on like the main end. So like here, the main end is this board, and then the other end is the driver. Rudiger says, I would have just had all the wires hanging out the side in varying wrong lengths. Yeah, it's... Okay. It's not too bad then. And Fluzzy says, still cleaner routing than most of the server rack side cable. Nice. Good. I'm glad it's not too bad. Yeah, so these cables here are for the brush driver, and then you can see there's this white one here, but that white one is not alone. It's not the only cable there, because you'll see that there's 3 other pins that connect to this plug here. And those, I needed to sneak them all in through this little gap between the JST pin and the black, whatever it's called, DuPont header thing. And so I made them all go vertically, which I think looks kind of cool. And in hindsight, it would have been more cool if I like mirrored the same colors here. So it was like yellow on the inside of both, and then green, and then blue, and then white. But I didn't do that. I just wasn't thinking about it. yeah, so I kind of like that section, but I don't like similar sections in here. Like in here, you can only really see like maybe like 6 or 7 cables, but there are some sections here, like in here, where there's like 4 or 5 cables deep, and you really just cannot see, like even by hand, if you turn the thing around, you just can't see the cables underneath, which I don't love, but it makes it nice and compact. Now, the one kind of dodgy thing that I still maintain was a good idea in principle, but I butchered the implementation of it, is for the longer CAN cables here. The green and the white one here. Sorry, green and yellow ones here that are twisted. So this is where CAN from, let me get rid of me. CAN from Jugglebot or from like another controlling computer will come into here, and this will give like instructions for where the robot needs to turn to get the ball where it needs to go. This CAN out here is like an internal CAN for just this robot that will just communicate with the O drives that are on this robot. So yeah, system CAN comes in here, and then that goes along these twisted cables down to one of, I believe it goes to this CAN transceiver. Yeah, and because those cables are quite long, they had the ability to kind of like lift up a little bit, and like there was nothing really holding them down, so they were kind of like able to move around a little bit more than I would have liked. So I had what I thought was a clever idea, and I still maintain that it was a good idea, but yeah, I kind of fucked the implementation. Almost. It did work, but yeah, I had this idea of using a small piece of wire. Come on, I could zoom before. I literally tried this before the stream and it worked. Whatever, no zoom. Maybe you guys can zoom on your end. I used this little tiny piece of wire to hold down those CAN cables. So this little circled piece of wire is basically just like a loop that goes through the perf board, solders onto both like back side of the perf board, and is entirely purely there just to hold down the green and yellow CAN cables. And I thought I was so clever doing this. It was so good. Originally, it was not exposed like that. It did actually have its insulation on. But during this process of soldering and unsoldering and everything like that, I've learned a lot about how to unsolder in particular. And I want to talk more about that in a sec. But for now, the only important thing to know is that I was changing the temperature of my soldering iron quite a bit. I was going from 350 Celsius to 450 Celsius, back and forth and back and forth. And because I'll talk more about that in a sec. But one of the times when I was soldering this on, I was, without realizing, on the higher temperature, on 450 degrees, and that was high enough that it melted not only the insulation for this cable, like this was originally a blue insulation that you can see a little bit of in there. It melted that off, I think because of the super tight bend radius, but then it also melted almost entirely through the insulation of the green CAN cable here. It's not the whole way through. I checked it like with continuity with my multimeter, but it got damn close. I really want to zoom in on that because I think it looks kind of funny. So let's try this. How do I, yeah. Look at that. It's so not good. Not good at all. I don't like that when I zoom on this, it changes windows. But yeah, it's almost the whole way through, but thankfully not quite. And really, it was just luck that it didn't go the whole way through because I didn't realize that was happening while I was soldering it until I turned the thing around. I was like, oh shit, that's not good. So I like this idea, and it has worked well. Like, it does hold down that cable and stops it from wobbling around. But if you're going to do something like this yourself, I advise being a little bit careful with it. Yeah. Detroit M says, I have a 300 watt 3D printed filler dryer. Could I make any adjustments to the electronics to make it work for 220 volts instead of operating 110 volts? I'm not sure. I don't really operate with super high voltage things. Yeah, all of the electronics that I have that are like powered by mains, as far as I can tell, all of them, they have like either a switch to let you change between 110 to 220, or they just work for 220. Yeah, I'm not sure. I would ask ChatGPT that and then carefully check its answer, because yeah, high voltage things are, I don't know, you can hurt yourself a bit if you are not careful. Yeah. One other thing that I want to mention with this is a suggestion for anyone doing anything similar, and also for myself in the future, is that I'm super glad that I did the teensy and the CAN transceivers with the header pins like this. So that way, if I need to, and I often do, if I'm just like, especially with the wiring of this, I can just take these boards off and put them back on very easily. So now in the future, like if I accidentally blow up a CAN chip somehow, then I can just take the whole thing off, put a new one on, done. Same thing with the teensy. If I ever, for whatever reason, need to replace it, or if I like stop using Ball Butler in the future and I want to use this teensy for something else, I can just take the teensy off and it's no problem at all. I kind of wish I did the same thing for the buck converter, which is the black chip here, because getting the routing working on this was so tedious. And there are 2 cables that are underneath this buck converter that take out the 5 volts from that buck converter and also the ground to the buck converter. And they were obviously not possible to put there while the buck converter is there because they are like directly underneath. And I don't think I'm gonna be able to show it on the camera, but it's very tight in there. And if I had put that buck converter on a header that I can easily take on and off, then it would have been so much easier to put those cables through. Now, I did consider this at the time, and the reason why I didn't want to do that for the buck converter is because I was like, okay, the buck converter is handling power needs, and so it's probably going to be passing through more current than the rest of the chips that I have this header approach for. So it's probably not a terribly good idea to like pass it, to like have the main power connection go through like the pins, DuPont headers, and then into the perf board. I was like, oh, that's a bit, like, feels kind of dodgy. Like, what if that vibrates out or something? But all of that reasoning is flawed because the only things being powered by this 5 volts that's coming out of here is like the teensy, which is then powering the CAN transceivers, and then also an encoder. It's like 4 small, low current draw chips. And I am very confident that that DuPont header situation would have been no issue at all, and I really just should have done that from the start. Because I ended up having to desolder this, the buck converter. I actually did desolder it once. I would have liked to be able to desolder it again a second time after I put it back on, but it was just too damn tedious, and I didn't want to take it off again. Yep. But a good silver lining about this experience is that I feel very comfortable now using solder wick, solder wick, to like remove solder from a joint. In the past, I had a really hard time using this stuff. I was never able to get it to behave the way that I wanted it to. But then like 6 weeks ago or so, I found a video that it's not in the description right now, but I'll put a link in the description after this stream. This guy, Microelectronics, I can't remember what his channel is called. But I'll put the link in the description later. And he basically just goes through like all of the do's and don'ts of solder wick. And I was like, oh my God, I'm doing like all of the don'ts and none of the do's. And now that I'm doing it the way that he was suggesting, it just works so much better. One of those things being using a higher solder temperature. I previously used to solder at like 335 degrees Celsius, and I use this solder. This is the only stuff I've ever had, and it's worked quite well for me. Loctite brand, it's pretty good. But using the solder wick at 335 just like never worked for me at all. If I bump that temperature up to 450, it's super easy, it just comes right off. And as well as the other tips that he has in the video, like namely having really small pieces of wick. But I'll link the video and you can watch it if you want. Yeah, so overall, I'm pretty happy with this. And there's the bottom here as well, if you're curious. One thing that, I don't know, I'm curious to know if anyone has any better suggestions for this, because I wanted these 2 long rails to be my like 5 volts in ground, because there are a couple things that take from that. And also having the ground being like a long one means that it's very easy to join things onto the ground. And I wanted to label these, and I used permanent marker, but it's really not visible on here. And I don't know, like maybe like a paint marker would work better. I'm not sure. But also here you can see the sketchiness of this. Maybe I can zoom now. No, the sketchiness of this Verra board, which this red cable here is kind of covering it up. But this is not a Radio Shack board; it's a Radio Shake, spelled SHAEK, presumably to just get around copyright. And like all of these holes are not quite lined up with the brass or the copper plating, which did make soldering a little bit annoying. But as far as I can tell, all the connections are fine. So it seems to work. Yeah, so all things considered, this is quite good. And yeah, I'm fairly happy with it. And the way that I've structured things here is that I've got all of the inputs coming in on what is currently the left, and then the outputs on the right hand side. So like CAN 2 is the internal CAN just for this robot. CAN 1 is the CAN that will connect to the external system. In this, right now, it'll be Jugglebot. 12 volts in is obviously 12 volts in. And then these, what are they called? JST connectors will go out to the various things that you can read on the plugs here. Very nice. Yep. Yeah, so I'm quite happy with it. I think it's turned out quite good. Cool. All right. CAD updates. So you may remember last week I mentioned that it's hard to read. Do what Solder Weeks do's and don't. I can't read that. Yeah. You may remember last week I mentioned that I didn't want to reprint the base for Ball Butler because it's a fairly large part, and I don't love making waste and like having to, I don't know. Yeah. I just generally don't like printing things that are just going to be chucked out, especially things that are this big. And I was really hoping that I'd be able to just print this off once and it would be done. Unfortunately, that wish has not come to pass because I did print it off and there are several mistakes with this that I will need to be fixing. One of them is that the holes are great. So you may remember last week I mentioned that because I don't know exactly where I want to be mounting things onto the base, like I've got all of these electronics in here, and potentially even this slip ring mount will be a separate piece. Maybe, probably not anymore, but I'll talk more about that in a sec. But there are things that I'll just, like, I want to be moving around. And also cabling will be in here, and you can CAD cables in Onshape, and you can like design where all the routing should go, but it's a little bit tedious to do, and it's hard to like mimic the stiffness of the cables in the CAD. So I'm not going to go down that route right now. So I need to be open to being able to put these cables kind of wherever I want. Music, I will answer your question in just 1 second because I want to roll. And I thought, okay, cool. Because I don't know where I want to be mounting these things, I will cover the base in all of these little holes, and these are 2.9 diameter holes, so they will fit an M3 screw perfectly, and I'll be able to mount things wherever I want, and it'll be really great, really nice. Lots of options of where I can put things. And I'll show you just quickly what that base actually looks like, so you can see, maybe you can predict what my problem is with this, that I noticed as soon as I printed it off. It was so obvious immediately. So this is what the base looked like when I printed it off. And I was like, yep, awesome. I've got lots of holes to mount things. But as soon as I took it off the print bed, I looked at it and I'm like, huh, where's the center of this? I need to mount the slip ring. The slip ring must be, like this blue mount right now, needs to be directly in the middle of this so that it lines up perfectly with the rest of, like it needs to be concentric so that everything rotates together. But because I didn't make any clear indication of where the middle is, like I could obviously go to the CAD and be like, okay, 1, 2, 3, 4 holes over. But because I didn't make it very obvious where the center actually is, it's very hard to tell on the physical thing. So it's, yeah, definitely, yeah. I definitely recommend if you're going to do something like this, make sure there's some kind of like indexing feature so that you can actually see on the physical thing where important aspects of that design are. That was, yeah, very silly. Yeah, even just like not having the hole right in the middle would have done it. So I can see exactly where that middle is, yeah. Music, to answer your question, I am building a butler for my juggling robot. I just went back. I need to undo this suppress. So this robot will it will have a hopper of balls next to it that is yet to be designed. And it will be able to basically move in whatever direction I want it to. So it'll be able to orient itself so that it can throw a ball to wherever I tell it to. So I'll be able to say, hey, throw a ball 1 meter in front of, like 1 meter, like I'll give it like specific XYZ coordinates essentially with respect to where it is. And then it will be able to orient itself where it needs to go and then throw that ball so that the ball will land exactly where I tell it to. Hopefully, well, it should be able to throw it not only exactly to where I tell it to, but it will land, the ball should land at exactly the time that I want it to land at. So yeah, this needs to be able to orient itself and then throw very precisely. Yep. Yep. Yes, so let's get back onto the base. Yeah, so the holes are great, but where's the center? Who knows? Kind of annoying. I've also decided to go with an amphenol connector, which I was originally planning on using Deutsch connectors, but after a little bit of like physical mucking around with what that would actually be like, I decided that this amphenol connector would be a bit better for this purpose. And I quite like how it looks on the actual thing, like it sticking out the back of it. So this is with the, so like these things are like so intense. Like, they're crazy connectors. So like this end will connect to the cable, obviously, and this will just be sticking out the back. And then, yeah, when we want to plug it in, this just goes in. And then if I want to be really extra secure, I can screw that in. And yeah, it's quite good. And I think I really like the aesthetic of this. I will probably, given that I'm going to be reprinting this base anyway, I'm probably going to be setting this inset a little bit further so that this doesn't stick out quite as far when it's all together. But for a first version, I think this is pretty decent, and it shows the possibilities. But you may notice that it's all warped around the connector, and that's because I was a little bit lazy with my modeling, and I basically kind of rushed the modeling of this connector itself. And so when I Boolean removed that component from the base CAD, the hole was a little bit too small, and I don't know how I need to buy a whole reamer to like allow me to drill bigger holes out. But without a reamer, expanding the diameter of a hole evenly is really, really hard to do. I tried originally I tried using like an X-Acto knife to cut around, but that did not work at all. I then tried using my soldering iron with like a blade tip to like try to cut around, and that kind of worked, but it's extremely hard to do that evenly. So I did that kind of like enough that I was able to like get a little bit of the connector in, and then I was like, okay, now that it's mostly big enough, maybe I can try hitting the whole thing with my heat gun. Well, actually, originally I tried hitting the connector with the heat gun to hit the connector up heaps and then push that in, but maybe I just didn't heat it up enough, but that didn't really work. So then I was like, okay, I'll just heat up the entire thing with the heat gun and then I'll press it in. And that did work, but only after it cooled down did I realize how much that warped the area around. And I don't know if that's, come on, focus. Yeah, it's really not great. It's very obvious when you look at it. It's like, oh, geez, that looks kind of crap. So I've obviously fixed the cut up, and that should not happen next time. Get a step drill. Interesting. Okay, I've heard them called reamers, where it's like a conical kind of thing. But you're right. I do need to get one. Yeah, that'll be a very useful tool to have. Yeah. What other oversights did I have? Oh yes, the PLA shrunk. So this is the first time I've experienced this. So this piece is obviously quite large, and I have heard reports of different filaments will shrink at different rates after they've been printed, and PLA seems to be, I don't know, not one of like the worst offenders, but it's definitely one of the ones that does shrink after it's been printed. And I definitely noticed that. So of course, like just looking at it, it looks fine. But once I line up the top part, like this big bearing onto here, it became very clear. Like I put in like one of the screws and that lined up perfectly fine, obviously, because it's just one. But as soon as I went to put in the other ones, it was really hard to line them all up. I had to really force it to get them all in there. And I didn't love that. It was much more annoying to screw the top part down, to like put these 4 screws in. It's much more annoying to do that than I would have liked. And it's possible that if I just print this out of a different material that doesn't shrink as much, or that like holds its shape a bit better, then maybe this would be better. But I'm wondering if there's a better way to attach these 2 parts, where there's like this base down here and then this top part up the top. And I'm thinking maybe if I had like, I have actually I'll just show you in the CAD. At the bottom of these arms that like rotate up and down, I've got this dowel pin, and at the end, and this is an M8 dowel pin, and at the end of it there are 2 like on each end, there's an M4 threaded, like it's internally threaded on the inside. So you can put an M4 bolt straight into the dowel pin, which is very cool. I'm not actually using it in that case, but I'm wondering if I could get like M5 dowel pins and I could insert the dowel pin into the base in here. Again, this would require that this hasn't shrunk, so it would have to be printed out of a different material, or I can just like account for the shrink. But what I'm thinking is I can put the dowel pin into here, and then that way I can just slide on the big bearing on the top, and then to secure it to stop it from lifting up, if that dowel pin had internal threads into it, then I could just screw like an M3 bolt, or whatever the size bolt is, into the dowel pin to then hold it down. Thinking that should work, but I need to have a look to see if I can actually find dowel pins that are like that, because I need to just have a look around. I feel like that should be better. I like the idea of being able to just kind of place it on, have it like concentric. I like the idea of being able to place it on and have it be forced to be concentric without needing to screw anything in. Because having to screw all of these 4 screws in and then be able to finally then be able to step back and say, okay, now what was I checking again? That's a bit too much faff, and I don't love it. I was also thinking of some kind of like clasping mechanism that I can like latch it down with, but I don't know. I'm really just like kind of fingers crossed that I can find a dowel pin, like an M5 dowel pin with internal threads, and it has to be M5 so that it fits into this big bearing. Yeah. I mean, worst case scenario, I can just stick with what I've got here and then change the material that I'm printing with to hopefully have less shrink. But yeah, we'll see how we go. Rudiger says a reamer will only size a hole to the reamer size. So you need many different sizes. Oh, okay. I think I'm getting my terms wrong then. I think, yeah, step drill is the one that I'm thinking of, where it's like a cone, but like it's not like just conical. It's like, yeah, steps the whole way along. Yeah. And Rudiger says use threaded rods instead of pins. That could work. And have like a nut on the top. Yeah. I don't love the idea of having like the thing that would be exposed on the top would be a nut. I'm not a huge fan of that. But that could work. Or maybe even using, like if I had the holes that went through into the base. Here. Maybe instead of these holes being sized for the M5 bolt immediately, I could have them stepped so that at the start, like for this depth, they are like slightly bigger than the M5 bolt. And then after a little while, they become a little bit smaller to actually screw in. So that way I could insert the bolts and it would like line everything up concentrically, but it wouldn't clamp it down until I then started screwing them in a little bit deeper. That could work as well. Yep, that's interesting. I'll have a think about that. Did you ever get anywhere with the emoji keyboard? Unfortunately not. Yep, it's still frustrating me every day. Or the Onshape export? Yes, I did. In a couple minutes. Probably be like 10 or 15 minutes, I would guess. Let's see how wrong I am on that. Yep. Okay, another big oversight that I had in this is that there is no, like there's only one port on the base to have anything come in or out. And that's the Amphenol cable here, which will be the CAN cable. So there's 4 pins here, CAN high, CAN low, 12 volts ground. But there's no way for me to there's no way for me to like change the code on the Teensy once this is all put together. If I built this the way that it is right now, I would have to upload the firmware onto the Teensy, close the whole thing up, going through all that faff that I was just talking about with putting the lid on, and then test it out, hope that it worked, and if it didn't, I'd have to take the whole thing apart, reflash the firmware onto different firmware onto the Teensy, and then do that whole thing again. That's no way is that going to work. Not a chance. So I bought a micro USB extendo thingy, like a female panel mount to normal male, and this way I'll be able to plug this into the Teensy and have this in all the time. So that's just going to be connected in like that. And then the panel mount will be sticking out, and that will be exposed somewhere on the base. So that way, if I need to change the firmware, I can just plug into that exposed port and it'll be super easy and ready to go. Yeah. But as the base is right now, there's no spot for that, and there's no chance that I'm going to cut that out by hand. I'll just print it exactly how it's supposed to be. And Rudiger says you can get cup nuts if you wanted to look better. That is a very good point, and those do tend to look nice. Yep. I'll have a think about this. Yeah, I like that suggestion. Thank you. And okay, yeah, so a big one is how to do the cable routing inside the base, because, ooh, that was a bit of a spoiler. So inside the base here, there's going to be cables running in like from the Amphenol connector over here that will come into 12 volts in CAN, and there's going to be there's going to be a whole bunch of cables in here. Yeah, you can hopefully get the idea. And I don't really like the idea of cables just kind of being loose, especially if any of the cables are long enough to find their way into the gears. That would really cause problems. I don't want cables in my gears. That's no good. So I want some way to be able to lock the cables down onto the base, but because I don't know exactly where the cables are going to be, I need some kind of like universal way to mount these cables down. And I found, after a little bit of searching around, I found this multi-board stuff. And there's links in the description for both of these things that I'm going to show. And this stuff looks very, very cool. So the general idea here is that these little octagons, I think they are, and the holes in between have lots of features in them for you to snap things into. And you can get all sorts of different accessories for this that basically just snap in, and yeah, you just pop them on and then they're stuck on. So you can have all these different channels. So I'm probably going to be using some of these kinds of channels where I can like route the cables through and then just snap it down. But you can also get like brackets for like mounting. People use this for like wall mounting, like here you go, under the desk mounting. You can like really go pretty crazy with it. It seems like one of those things that, I don't know, you can kind of go to the moon with how crazy you want to get. So what I'm thinking of doing is downloading this giant tile and then basically Boolean merging it with the base so that it just like covers the entire base, or like at least the regions where I want to have this universality. And then when I want to mount the cables on, I can just print off the channels that I want and then snap it down, and it should be really easy to go to be modular, and I can put things kind of wherever I want. So I'm pretty keen for that. I think that will work quite well. Yeah. And okay, yeah. So next CAD update. So that's everything on the base, and I feel like if I make those changes, then I think the base should be pretty solid. I will also actually, I didn't put anything in the slides for this, but I have actually received this slip ring now, and it's quite cool. I love slip rings. They're so much fun. So like, it's poking out the back here. This is the static part of it, and the rotating part is now hidden inside the top. And this is like rotating just on the slip ring. Like the bearing can also rotate separately, but it is much harder to rotate than a slip ring is. But yeah, it's super, very nice. Very, very, very nice. I'm very happy with that. But as I suspected, there's not really any way to mount the slip ring, and I'm probably just going to have like a tolerance, like an interference fit. But now that I actually have it, I can take the actual dimensions off of it, and I know exactly how flexy all the cables are. So I will probably do a cable routing system for this thing that's here that's labeled cables. Let me hide this. There's all the holes there annoying. This thing here labeled cables are the static cables coming out of the slip ring. I will probably make a channel for them that's similar to this channel here that's there for the encoder cables. I think that should be fine. Yeah, so that's probably going to be attached onto the base permanently, just fixed there. Yeah, I think that's a bit simpler. Yep. All right. Cool. The next CAD update is on the main ring. So I started putting all of this stuff together, and I really like how it's coming together, and it's amazing how obvious some things are once I have the physical thing in my hands that is not obvious in the CAD, but like now that I know that it's this way, then in looking at the CAD, it's like, how could I not see this? It's pretty interesting how, like, even though the CAD is like a perfect one-to-one representation, there's something about having it in your hands that makes it easier to imagine, especially with cable routing. This is a big one because it's hard to predict where the cables are going to go in the CAD. But yes, so one of the things that I did is, you can see as I showed before, I've got the slip ring inside the lid here, and I've put the cables through because I just wanted to get an idea of how the cables would sit in here. And I have hope that I will be able to get the cables to sit like along this back spine. And I will be putting these cables inside some kind of cable sheath as well, so they'll look a little bit neater. But I have hope that we can get these cables to sit in this back corner here, and that way as the arm moves up and down, they will just kind of do this sort of thing. I have faith that that's possible. But to make it a little bit easier, and to make it so that the cables kind of want to sit in there, what I've done is, and this is one of those super obvious things that I should have done way earlier, but it didn't feel obvious at the time, is to make a channel in the back here so that the cables will like want to sit in here. This does mean that I've had to move the cable tie slot out a little bit, but that's completely fine. So yeah, the cables will basically run through this curved channel here, up over, get cable tied on, and then run up through this this sleeve channel thing up the back. And I'm thinking that even if the cables don't want to stay in there and they kind of like find themselves falling out to the sides, I'm thinking that it could work to, if I drill a hole, maybe multiple, but hopefully one would be sufficient. I could drill a hole through the back, and I could put this in the CAD, but I'm hoping that I won't need to do this, so yeah, and drilling one hole should be fine. But I can basically drill a hole through the back here, and then put an elastic band through, and then run that elastic band to the cables, and that way the elastic band can just stretch when the cables get pulled out, away, like when the arm... actually, I've got that open here. So when the arm tilts down, if it will move... Come on. Why do you not move? What? I'll just refresh the page. Yes, basically, so as the arm moves down, the elastic band will stretch and allow the cables to move a little bit away from the main ring. But then as the arms come back, the elastic band will compress. There we go. The band will compress and pull the cables back into this back section here. And Rudiger's saying 3D print a cable tray for them. I was thinking about printing a, what are they called? Like the arm, like the cable routing sleeve things that CNCs use that can bend along one plane. I was thinking about that sort of solution, but it seems like printed versions of those are very janky and not like super robust. And it's a little bit overkill for this situation. I kind of want something that's a little bit cleaner. And I don't love the idea of the rubber band, and I'm hoping that I can find like a black rubber band or a red rubber band that will kind of blend in. I don't want to use like one of the standard brown ones, but hopefully we don't need that at all. Yeah, but I reckon this channel should work quite nicely. Yep, and I think that's the only update I had to make on the main ring. Oh, okay, there's a cable trace. Okay, yes, nice. And yes, the last one is the motor support arm, which I have only made one change so far on, and that is to put this ferrite bead in here. And yeah, space is very tight here, and I want everything to be very compact, and I'm kind of proud of this. I went to a bit of effort to braid the cables that will run up from the encoder down here. So this will be the encoder that will tell the O drive what angle the arm is at, so that the output of that encoder will run up through these nice braided cables, which are not really coming up on camera very well. They will run up to the O drive up the top there. Yeah, I'm quite happy with that. And because I want to minimize the amount of cabling through here, I'm just going to take the motor cables directly from the motor, and those will go straight into, obviously, the only reason why I have these connectors on here is just like stop the cables from untwisting. But these 3 cables from the motor will just go straight onto the O drive. And as I mentioned before, I don't love, from what I can tell, brushless DC motors make a fair bit of electromagnetic noise. And if you're running your encoder cables right next to your motor cables, there's a decent chance that noise will get into the encoder cables and play and wreak havoc on your encoder signals. And that's going to make it really hard to tell like to get accurate information from the encoder. So it's a good idea to put the brushless DC motor phase cables through a ferrite ring. And ideally, you want to loop these cables through the ring as many times as you can. But yeah, that as many times as you can is a very different number based on the other constraints that you have in the system. And here, I really want this to be very small because I'm ultimately going to be putting, hopefully I'll get to this today, is to finish the CAD for this component. I want to make a cover that will magnet, hopefully, onto this and keep this all really nice and sleek. And I don't really want to have this be like bulging out for the only purpose of like wrapping a bunch of lines through the ferrite ring. I want to try to make it really as small as I can. And yeah, so ideally you want loops through the ring, but as it turns out, even just passing the cables through the ring just one time like this helps a little bit. It's better than nothing, as far as I can tell. I don't know if as far as I'm aware, I don't have the right tools to be able to measure this. I don't know what the right tools would be, but I don't think I have any tools that can measure the electromagnetic noise coming off of this. I probably do if I got like really creative, but it doesn't bother me that much. But as far as I can tell from looking online, passing the cables through the ring just one time is better than nothing. So my plan is to have a little indent in the motor support arm, and the ferrite ring will just sit in there, and then that will allow the cables to pass through just that one time before heading into here. And this yellow terminal block will not be here. That's just there because I haven't updated the CAD yet. So these cables will be soldered directly onto the O drive. Yep. Yeah, Rudiger says, actually they would be called ducts or trunks, not trays. Yeah, trays didn't seem like the right word. That seems like more too static for something that can bend like that. Yep. So there was one other big thing that became very obvious to me as soon as I started putting this wiring together, and that is how I should get the cables to this O drive from down here. So like these 4 cables that are coming up, I'll show you in real life now that I can. We have these 4 cables coming up through from the slip ring. We've got black and red, which are power, and brown and orange, which is an interesting combination choice, but it is what it is. And these will be the CAN high, CAN low cables. And those 4 will need to run to both this O drive here and this O drive here. I'm still a little bit unsure as to how I'm going to position this O drive. I'm kind of thinking that having it turned around might be a bit better, but that aside, for this O drive, we need those 4 cables to come up, and 2 of them will come up into this yellow block, and the other 2 will come up into one of these blue blocks here. And previously I was really not sure how this could work, but as soon as I started holding this in my hands, it just became super obvious. And what I'm going to do, I obviously haven't cutted this yet, is I'll have 2 channels that will run, might be easier if I draw this. I'll have one channel for the 12 volts and the ground, and that will run through like this. Let me get rid of that one. And then the other one for the CAN will run through like that on the other side. So we'll have 2 like cuts in through here that will basically, like the power ones will enter somewhere around here-ish, where that circle is. And then the CAN ones will enter similar, like around there at the top. And then they will both exit on this face over here. And that should allow me to very easily, like that's like right next to this O drive here. So that should be very easy to bridge that span, especially because as this moves around, like that's never going to intersect with anything. So that should be pretty fine as far as that goes. And then I should only need one connection out to where the cables get to over here. So I think that should be kind of neat. Yeah. You're talking about suppressing eddy currents using magnetic ring. I don't think eddy currents is the right term. I'm pretty sure it's like electromagnetic noise. Like if you have, like through the 3 phase cables, if you're like, as you're powering the motor, I think especially when it's like in a high torque situation, which this motor is not really going to be doing, but better safe than sorry. But yeah, as far as I can tell, if you put the motor in like a really high torque or high power situation, then there'll be quite a lot of noise coming out off of those cables. And having those cables pass through the ferrite ring does magic electronics things and suppresses that noise. Yep. Magic electronics things is the technical explanation. Yeah. So yeah, I need to cut those channels through and then add a cover on here. And there's one other maybe thing that I'm thinking of doing, which is that, so I've been a little bit sneaky with how I've been putting this together, and I have actually physically put together all of this onto the actual base while it was all attached, and I could kind of get a feel for how everything was fitting together. And it is significantly more stiff than the last one was. Like I can't wobble it side to side at all once it's all together. So I feel quite good about it, but I do think it could be made a lot more stiff if I had some bridging between this part and this part down here. Because right now, this motor here is what's acting to pull this up and down. And what we're trying to push up and down is this side, is like this arm that can slide up, like vertically up and down. And the only thing that is transferring this angular motion to the aluminium extrusion on this side is this little, currently 3D printed, but it will hopefully later be aluminium spool. And I don't love the idea of having all of that motion transferred through such a minor part that will also be rotating as well. So it's like other concerns there. So I've been contemplating having some kind of like brackets that I can span this gap with, and I expect that will massively increase the stiffness of this system. So I'm kind of considering doing that as well, but it's a little bit awkward to do that, I think. Yeah, I'll have to see how I go. Yeah, but that's on the cards at least, and I'm curious to know if anyone thinks that that's probably a good idea, because I don't know. I do think it's a good idea, but I'm also like mindful of the effort that it would take to do that. So we'll see what I end up doing. Cool. All right. I have done more experimenting with my printing, and I now know how to get smooth curves out of 3D printed parts. And I'm very relieved about this, because you may remember that my last main ring that I printed was, I kept calling it stair-stepped, and that was the wrong word, was faceted. And you can see it very clearly here. You can see all of those little facets as we go along. And I don't want those facets there. Honestly, it probably won't really be detrimental at all to the actual operation of this, but it looks a bit crap. And it's definitely not going to help the operation. So I don't really want those facets to be there. And I postulated that maybe I had postulated is a bit of a strong word, but I had read online that step is like, if you save your file as a step file, that will allow you to get arbitrarily high resolution on your parts. And it turns out that is correct. That is the way. And I have here an example to show you. It's actually the same example that I used last week that I was a bit kind of like umming and ahhing about. But it turns out I was just looking at it the wrong way. So here, exactly the same as last week, we have the 3MF import and the step import, and I'll keep me here. And what I showed last week was just to do with like the motions of the nozzle as it was printing around. And I think that's a bit of a flawed way of thinking. And honestly, I actually do think that showed that it was a high resolution, but it's not really obvious. It's kind of hard to see exactly what that what the outcome of that will be. But there's a much easier way to do this, to see the quality of the component that you've brought in. Because if you're just like looking at it in here, it's like, okay, it's like, okay, I can actually see the facets on there. And this one I can't see the facets. So honestly, actually just zooming in maybe is the secret. But there's a much more obvious way to do it, which is to go on this simplify model. So if you right click on it, simplify model, and if you show the wireframe, and if you go into decimate and you decimate it 0%, like this is showing what it actually is, you can see this wireframe very clearly, and you can see exactly where all of these facets are. And so you can see this one's like, yeah, they're pretty big facets. But then on this one, if we simplify model, decimate, we want 0 decimation. So we want as many triangles as there can be. Look at that. Much, much, much better. Much higher resolution. However, this does come at a cost of a much higher file size. And so I can't remember exactly how many triangles. Okay, here it says, this one has 72,000 triangles, this step import, and that's the wireframe that I just showed. What I ended up doing when I printed this off, and I have the final, I'll show you the final result before the model. This is beautiful. This is super, super clean, very smooth the whole way along. This, I could not hope for anything better than this. This is like a perfect print as far as I'm concerned. Whoops. Very nice. But what I ended up using for that one is I didn't use this 72,000 triangle thing. I thought, I'm only going to be printing this off once, so let's just go crazy. Let's see how many triangles we can get in here. And I ended up using this version of it, which I was exported exactly the same way. I just export as step, but this is the updated version with the channel cut into it. And this one has 1.6 million triangles. And if we look at the simplify model and we have 0 decimation, look at that. That is nice and clean. So good. so good. But as I said, this does come at a cost. And the full file for this version that has the step and the 3MF version in it both at the same time, this one is 1.2 megabytes. This one, with just the one file, is 25 megabytes. So depending on what you're doing, it can be advantageous or not to do this, and you should obviously consider your computer storage space if you're doing this a lot. But yeah, for now, I feel very good that I have solved the curve problem. I'm very relieved about that. And I will also note, for my computer at least, if I'm importing something and I'll show you what that import process looks like because I haven't explained that. So if I'm importing a step, let's say we get this one. Here you can set the linear deflection and the angle deflection, and you can go on the wiki and it tells you a little bit more information about it. But it tells you more stuff about it. But basically, the larger this deflection value, the less resolved your part will be. So if we go like really high resolution on both of these, this is only going to have 11,000 triangles. And let's lay it flat. Yeah, we can already see, look at all those facets in there. Like that's not that great. But then if we increase the number of, if we decrease the deflection like really low, then it suddenly takes a really long time to calculate all the triangles. And I have found that as long as I have less than about 500,000 triangles, it takes like a couple seconds to load the part. But as soon as I go to more than 1 million triangles, it really starts to take some time to process the file. And like my computer, I don't know if you can hear it, but my computer is really whirring away right now. And I don't want to drag it too much because I'm doing the stream right now. But yeah, hopefully you get the idea. So for this one, I obviously just like imported it, went out and, I don't know, took a walk or had a bit of a break so that it could import. And then, yeah, it's from that point on, it's pretty fine to process. It's fine. It's just a little bit slower. And this makes me think, why would you ever export as anything other than a step file? Like, from what I can tell, we have STLs are like the worst you could use. It's just triangle data, just a mesh. That's it. A 3MF is an STL with other data as well. And like 3MF stands for 3D manufacturing file, which is why I originally changed from STL to 3MF, because I'm like, 3MF, 3D manufacturing file. I am manufacturing in 3D, so that's the file that I want. And all that is a step with other information in there as well. And if you didn't already know this, if you go to any 3MF file and like unzip it, like if you right click unzip, it feels kind of weird because it's not a zip file, but you can unzip it and you can see it's just a an STL and other information about the part, which is very helpful if you're working on like a project where you're printing a lot of things and you've got like a lot of different components and you've got particular 3D printer settings and you've got like these ones need to be out of these materials and I want these colors for these parts. That needs to be a 3MF because the 3MF will store all of that like metadata. But if you just want like accuracy and like if you're exporting from your CAD system, you're not going to be exporting probably, at least I don't export all of those material needs or anything like that. So you really just want like the best geometry that you can possibly get. And as far as I can tell, that is step. So step, from my understanding, is like a vector-based definition where it will like analytically describe the geometry so that you don't have any wireframe at all. Like you can go arbitrarily finely resolved if you want to, and you'll just have infinitely number of triangles once you convert it into a 3MF, which you have to do when you go to print it. So yeah, I'm kind of like, I don't know why you would ever export as anything other than a step. I'm pretty sold on just converting as step every single time. Or exporting a step every single time. I'm curious to know if anyone has any thoughts to the contrary on that. Because I'm now a convert. I'm a step man. Which takes us to exporting from Onshape and the trials and tribulations that are in here. So, to give some context here, if you're in Onshape, and let's say that I'm ready to, like I've done all my CAD and I'm ready to export this main ring here. What I need to do is right click, go down, export, wait for this little window to load, make sure I'm on the right file type, which now that I'm always going to be exporting a step should be pretty straightforward because it'll just stay a step and it usually remembers what you last picked. And then you click export and you wait a little bit and then you get the little Chrome notification and then you know that it's done. You go download started, yep. And then you can go into your printing software and off you go, the slicer, and off you go. But I don't like doing that. I don't like the right click, the go down to export, the wait for this to load, make sure the format's correct, and it's a lot of faff. And I don't like faff. I really want some way where I can just press a button and it will export what I want to export. And this, I don't know if I want to say thank you to Fluzzy for suggesting this, but man, this is a rabbit hole that this has opened up a little rabbit hole that I'm trying to stop myself from jumping into. Because I'm pretty sure the only way to do this is with an API through Onshape. And APIs can do a lot of stuff, and they can definitely do this. This definitely works. Where we basically have, I'll show you my Python code, and there's a link. Oh, I've uploaded it to GitHub, but I didn't put a link in the description. I'll put a link in the description to this code after the stream is ended. But we basically have a Python code that will call, so we go into export parts. We basically call the API with specific information about this document that we're in. So like my intention here is that we would be in a document, like let's say we're in here and we want to export this assembly as it entirely is as a step file. So everything in this assembly will be exported inside the step. The way that this works is Onshape has divided up the URL into particular sections. We've got like, this is the document code where irrespective of what tab you're inside this document, this code will always be the same. This next one is the workspace, and you can see that the W there is for the workspace. And so this, as long as we are in the same version that within the same version, this code will always be the same. And then the last code, the E one, is the, what do they call it? Like the specific tab that you're in. So like this stage 2 assemb has this code. If I change to a different tab, like the encoder mount, if you're paying attention, you may have noticed that this code is the same, but this code has changed. And so this is a way to basically figure out exactly what tab you're looking at. And if you send this information through the API, then you can, if you've done everything correctly, you can export that part. You can basically tell Onshape to export. And I have it set up so that I write to my downloads folder, so that if we're in the assembly mode, we will export the entire assembly as a single step file. We name it based on what the tab is called. And then if we're in a part studio, every single part will get exported as a separate step file, and it will be named what that part is actually called. And I thought I was hot shit after I got this working. This is obviously ChatGPT did the bulk of the code here, but like as with all ChatGPT things, there's a bit of human work that needs to be put in to get this to actually work. But this Onshape export parts works quite well. I can run this in the command line. If I manually put in the document ID, the workspace ID, and the EID, whatever that one is, I can't remember, the element ID, I think. If I manually put this into the terminal, it works great. But of course, if I'm exporting, I don't want to have to manually copy those little bits of the URL and put them into my terminal to then export. Like, it's much easier to just right-click export. So I need some way to be able to call this Python script and automatically put in the DID, WID, and EID. And this is where AutoHotKeys comes in. And this is the big rabbit hole that I'm kind of like regretting learning about, because my God, if you want to automate something in Windows, if you want if you want to automate anything, you can do it with AutoHotkeys. One that I've seen that I'm actually kind of, when I first saw it, I was a bit like, oh, like this is a bit of a, why would you want this? But now that I've had a bit of a think about it, I'm like actually keen to do it. Someone had one where if they move their cursor over the like Windows search bar and scroll, it will change the volume of their like music that's playing. And originally I was like, that's a bit of a gimmick. Like, why would you want to do that? But just the other day, like yesterday, I was doing work and I moved my keyboard out of the way so that I had like this desk space available for me to do work on it. But I wanted to change the volume. A song came on that was a bit louder than the others and I wanted to turn it down a bit. I'm like, oh fuck, I've got to like get my keyboard out and then press the volume down button. But if I could just move my cursor over the Windows search and scroll, that's pretty good. So, and Fluzzy says, AutoHotKey is amazing. I love it. It's a shame it's Windows only though. But if anyone knows a replacement that's NixOS, I have never even heard of NixOS. Interesting. So my AutoHotKey, there's some very, very cool stuff you can do with it. Like this, it will copy I'll show you like I'll go through the process of what this does and then I'll show you the code. So what this is doing is it will copy the URL as it is in the, like I have to be in the Onshape window as like the active window. If I'm off in like File Explorer or Illustrator or anything else, or even just like a different Chrome tab, then this won't work. Like it automatically stops working if it's not an Onshape tab. But if I am in an Onshape tab and it's the active window, then it will copy the URL without affecting my clipboard, which is amazing. I don't understand how that works. So cool. We'll copy the clipboard and then take out the document ID, the workspace ID, and the EID, and then put those and like save those as variables, and then run the Python script with those variables put in, and then it will give me a little tray. Let's try it. I've mapped it to a Space Mouse button, so I can just press a single button, and it should download. But as I will explain, it like you can see when it works, well, when it like starts to work, when it highlights the URL. But for some reason, oh, there we go, that one worked. Okay, so I get a little, I've got multiple monitors here, and it doesn't come up on this monitor that I'm sharing with, but it will give me a little tray notification. You know when you take a screenshot and it's like, and like the little thing comes out the side and like it notifies you that you've taken the screenshot. I get one of those notifications telling me that the export has worked, and in that case, it did actually work. It's very nice, and that is a little bit of a spoiler for what I'm going to go into in a sec. But yeah, this basically copies the URL and then uses regex to take out the document ID and the workspace ID and the element ID, and then saves those as variables. And then we run the Python script with these variables in place, and then it gives us a little tray tip, basically saying, yes, the export has worked, or no, the export has failed. And this is so good. But it doesn't work every single time. I'll talk more about this in just a sec. And yes, it works sometimes. And big thank you to Fluzzy for suggesting this originally, like the API keys stuff. This is absolutely critical to this working. But I don't know why this doesn't work all the time. It just doesn't, like, I'll press the button and it just doesn't do anything. And you can see sometimes I get the little loading thing on my cursor, and that will just appear every couple seconds. So it's clearly doing something, but not the right thing. I don't know. I'm like, I got it. So I got it so that it was working every single time in my little like test environment. But then as soon as I rebooted the computer a couple times and was working in like more, I don't know, in like different Onshape environments, it just is not working nearly as reliably as I want it to the point where it's like kind of not that useful. Like I basically press the button. The export will always take some time, like even just exporting straight from Onshape, just the process of like converting the file into a step, that takes a little bit of time. So it's at the point now where like I try pressing it, and then if it doesn't work within like 5 seconds or so, I just like right click export. And it's kind of like against the whole purpose of doing this in the first place. And that's really frustrating me that it's like so close, but it has to be like perfect for it to be actually functional. Ah, yeah, toast notifications, because they pop up like toast, but it's like sideways for me at least. Yeah. So I will put all of this all of this code in a link in the description. And anyone who's interested in this, like this does work sometimes, but not every single time. And there's a couple other little things that I just want to mention that are required to be able to get this to work at all. One thing is that you need to set up your API keys in Onshape, and there are pretty good explanations for how to do that in the Onshape docs. But once you get those keys, you can either hard code them into this code, but because I wanted to put this code onto GitHub, I don't want to have my API keys in here. So you have to make this the separate file called, it has to be in your, in this location on your computer, uses whatever your username is, and then just straight in there, you have this _client config.yaml. And that should look like this, where you have the base URL is this, you'll have your access key here. Obviously, I have not copied mine in here as it is right now. But then you also need this default stack :prod API keys. I don't know why, but you do. If you don't have it there, it doesn't work. And if you have this in the correct spot, then when you call the API in here, it will automatically find those keys and it will do what it needs to do that export. Once you do this bit, it finds those keys and it works. You also, for the AutoHotKeys part, if you want to be able to restart your computer, this is a bit annoying. I wish I could show this, but actually I can here. Yep. On your tray table down the bottom, I just took a screenshot of this just then. You can see I've got two AutoHotKeys. These notifications come up when the hotkey is like running and like ready to accept your input of those whatever combination of keys you used. So I have two on here. I've got one for this Onshape thing and one is for something else that I've been doing now that I'm aware of AutoHotKeys. It's unrelated to Jugglebot though. And this basically tells you that this that the hotkey is running and is ready to go. And to be able to get that to appear so that the hotkey is ready to go every single time when you reboot your computer, you have to make sure that you have that. You can just talk to ChatGPT about it basically, but you just need like a shortcut to that AutoHotkey in your like startup folder. So that way when Windows starts up, it will automatically start those scripts and the hotkeys will be ready to go. Now, one thing that I will caution and that I have learned during this process is that I don't know about everyone else, but I use a lot of different programs and they use different shortcuts for different things. Like for example, OBS here, the way that I'm like changing these camera views, this is all with, I've like mapped them to keys on my macro pad, but those are all shortcuts. And I need to make sure, I really wanted to make sure that I wasn't like overlapping on my shortcuts on these things, because the programs, they don't know that different programs have the same shortcut if you accidentally map the same random keys to a different function. And so I now have like a document on my computer where I'm basically keeping track of all of the shortcuts that I'm using for all of my apps to make sure that they don't overlap with each other. And yeah, so it's so frustrating that it's like that close. And I've got it as a key on my Space Mouse and it's so good. I just press the button and then the export should work. That close. Yeah, very frustrating. But I'm trying to not sink too much more time into it because I want to just focus on other stuff and like actually get the job done. But if anyone else out there is keen to use this as well and perhaps has a bit more of an understanding of how this stuff actually works, then I encourage you to give it a go. And as it is right now, this code does work sometimes. I don't know what makes it work sometimes and what makes it not work sometimes, but yeah. And annoyingly, when it doesn't work, it doesn't tell me anything. Like even though I have in my, in the AutoHotKeys thing, I've got this like, if the Python script has run correctly, then we get this toast notification saying that it has worked. And if it didn't work, if the Python script did not run correctly, then we give like an export failed thing. Even though I have this in here, whenever this doesn't work, I get no feedback at all, except for that little loading thing on my cursor every now and then, which is very confusing. Yeah. So I'm not really sure where this is falling apart. But again, I'm trying to not sink too much more time into it, even though I really, really want to. It's so like, Flazy says, to prevent AHK shortcuts being a pain, you can use the hot if directive to only have hotkey active if you're in a certain... Interesting. That's cool. So you can basically tell it that if you are in a certain app, only listen to those hotkeys, and if you're in a different app, then ignore those hotkeys. That's very cool. AutoHotKey is incredible. I am trying to not read about all the different things that you can do with it, because I know that if I do, then I'm going to be very tempted to do them myself. It's very cool. It's very, very cool. Yeah. Thankfully, I shouldn't need that. I think now that I've got my shortcuts document that I'm very carefully checking with every single time I make a new shortcut, I don't think I should have any conflicts. And like, there's a lot of keys on the keyboard and a lot of different combinations of things. So I feel like it shouldn't be too bad, but that's good to know that that's a possibility. Yep. Okay. That's it for this week. Actually, no, not quite. There are a couple other little things cool things that people suggested that I buy, and I have, and I think they're very cool. So another one of those things is that I have actually bought a second type of slip ring. So the one that I'm using in actual Ball Butler has a hole in it, and that way I can put the encoder magnet in there. But I've also got this other one that does not have a hole in it. And these are just so much fun to play with. Like, the fact that these cables are like electrically connected, even though I can spin this around as many times as I like, I just find that amazing. So good. And I also bought an electromagnetic clutch that someone was suggesting for, I don't remember who it was, so apologies, but thank you for suggesting it. So we were thinking of potentially using a clutch when we were looking at doing the mechanical launching system with like springs, and whoever this was suggesting that I could have a clutch here, so that way the motor can wind up the spring with the clutch engaged, or whichever way it goes. And then when we want to throw, so that we don't need to backdrive the motor, we can basically just remove the motor from the system using the electromagnetic clutch, and that will allow the spring to get released without any impedance from the motor, or like mechanical impedance from the motor, and that should work perfectly fine. So yeah, I bought this. This is the smallest clutch that I could find on AliExpress that wasn't like crazy expensive. Annoyingly, it's 24 volts, not 12 volts, but it's very cool. And when this arrived, I was like, okay, cool. I have these bits, but like, what do I do with this? And it turns out the way that this one works, at least, is that this is an electromagnet in here. And when you apply 24 volts to the two wires, and I'm assuming that it doesn't matter which way they go. I tried it once and it just worked both ways. So I guess it doesn't really matter. But once that electromagnet magnet is on, that will attract this disc to it very, very strongly. This one is, I believe it was 0.6 Newton meters it was rated for, but you can get this from the same vendor. You can get ones that are like 75 Newton meters, I think. That's huge. That's so big. I don't know what you'd be doing with that, but I guess if you have a big robot, you need a big clutch, I suppose. But yeah, I'm still not exactly sure how, I guess it depends on the context that you're working in, is like how you actually position these things. But it seems, so Prop Guru, you said you've used this exact clutch. It seems like you need to have this ring mounted on something that is like on a spring, so that it can actually like pull into it. Or do you just have like a gap, and even with that gap, the magnet is strong enough to allow it to stop spinning? Or do you have it spaced so that it's like just not touching, so that way you can actually spin without issues? Yeah. And Prop Guru says, just to be sure, not Energizer for too long, a couple seconds max. Yeah, I'm very glad that I read the datasheet before I started playing around with it, because I did note that it says that. And I did have it running for probably 4 or 5 seconds a couple times just to like see it. And I was like measuring or like seeing the magnetic fields using this thing, where like, if I pass this over here, it's like, there's no magnets on here, but you can see the imprint of like when I passed it over when it was on, and like, that's such a strong field. Yeah, so I definitely had it running for probably longer than the supplier would have liked me to, but I'm not going to do that anymore. Barely space. Okay, yeah, so you have it so that there's like a little tiny gap. Interesting. Yeah, it'd have to be pretty strong support then to not have it snap on, because that force pulling it on is very strong. Yeah, interesting. So yeah, but for now, because we're not going to go down the path of the mechanical launching system, I don't have any immediate plans for this, but I just figured this is a very cool thing to use. And the more that I like make robotic systems, it seems like this sort of thing is going to come in handy at some point in the future. So I figured I'll just pick one up so that I have it just in case I need it. Okay, it should touch when energized. Yeah, okay. Yeah, so you're gonna have some kind of like spring system in there. Yeah. Interesting. And there's one other thing that I got, which is a kit of Lego gears, which, again, I don't remember who exactly suggested this, but it's very noisy. I really like this suggestion because Lego gears should make it a lot easier for me to prototype these sort of gear systems. And I think that this will, yeah, if I have any like conceptual ideas for like how can I transfer rotation from over here to, I don't know, linear motion over here, like what sort of gear train can I use to achieve that? I have a feeling that having these gears will make it a lot easier to do that. But annoyingly, you may have noticed when I held that up that even though this kit came with a heck of a lot of different types of gears, it didn't come with like any axles or pins or anything like that. So I'm going to have to buy like a second Lego kit for all those pins and all the connecting bits that actually allow you to make these systems. Yeah. Prop Guru says, oh, you think that was me? Good. Thank you, Prop Guru. Lego and Connect gears are thumbs up. Yeah, they are very cool. Very good. Some very random ones in here though that I don't really know what they are. Like these guys, like what is that? They're like drums of some sort. And some like, I don't know if these like big yellow guys, I don't know if those are canon. I don't remember seeing those when I was a kid. But yeah, lots of gears, lots of options. I just need to get some connecting pins. Cool. All right, so that's it. Yeah, so all in all, I'm very happy with how this went. So much tedium, but I'm so glad this circuit board is done. And I'm feeling pretty good about how Ball Butler's coming along. I've also noticed that this is my 99th video, so that means next week's stream, and there should be a stream next week. Next week's stream will be my 100th video, and that definitely gives me a lot of motivation to get to like push Ball Butler as far as I possibly can. And I do think it's within the realm of achievability to have this all together so that it can move and orient and probably throw as well. So I feel cautiously optimistic that we'll have a like functional working Ball Butler next week. The degree to which it is functioning is debatable, and I'm not expecting it to be out. I'm not expecting it to be at the point where I can say throw to these coordinates at this time and then it will just work. I think that's going to take a little bit of fiddling around, especially because one thing that I haven't actually checked yet, but I've been meaning to, is that for Ball Butler to be able to throw to a different position, if I'm giving it a coordinate, if I'm saying like throw to 0, 0, 0, like in the middle of the room, let's say, Ball Butler needs to know where itself is. If it doesn't know where it is, it doesn't know how to position itself to get the ball to that spot. And because this is not going to be like bolted down onto anything, it's probably going to be shifting around, especially like as my cat jumps up onto that shelf, that's going to shift the shelf around and probably shift this around. So it needs to be able to figure out pretty dynamically exactly where it is. Now, of course, I do have these motion capture cameras in the room, and I should be able to just put some markers around on Ball Butler and that we can use those to locate Ball Butler. But one thing I need to check is how good the viewing is, and like how many cameras can see that spot there, because I have calibrated and I've positioned these cameras for Jugglebot in Jugglebot's spot. And I think it's pretty likely that at least one or two of the cameras can't see that spot where Ball Butler will be. So I'm just like really fingers crossed that there are at least 2 cameras that can see that spot so that we can actually get some idea of where it is. Hopefully 3 or 4 of the cameras will be able to see it, but we'll see. Yeah, so that stuff is like, there's a possibility that will be completely fine and it's going to be a non-issue, but there's a non-zero chance that will become a problem that's going to be a bit of a pain in the ass to solve, because I don't really want to have to move these cameras around again. That was kind of a pain to get them all positioned where I want them. But yeah, so low, like minimum functionality, moving, throwing, I think is doable, which means that we should be very soon moving on to the hopper idea. So if anyone has any ideas for how to make any ideas for how to make a hopper that this can draw balls from, I would very much like to know, because I'm still leaning towards just like a long chute that will sit up on the wall, like above where my finger is, and that will just like have all the balls lined up in there, and then this will have some kind of like program that it runs through to just like collect a new ball from the hopper. But yeah, we'll see. Proku says rearrange the cameras is easier than rearranging the room. Honestly, maybe. Now you've gotten me thinking. Maybe I could even put Ball Butler on that shelf in here. If it becomes an issue, like having it on the very top, maybe I could put it on the shelf in there, but then I'll have to move all this other stuff. Yeah, it's a whole thing. There's so many different things to consider, but we're getting there. Yeah, it's coming along. I'm very hopeful that we'll have something exciting for my 100th video. It'll be a bit, I don't know. Obviously, it wouldn't really matter that much, but like, I don't know. It'd be nice if it was something cool for the 100th one. You know, triple digits. I thought it was going to be a lot longer to get to this point, but these live streams have really bumped that number up very fast. You stoked for me? Thank you, Prop Guru. Cool. Okay, so that's it. And to avoid rambling too much, my mum told me last week that the streams are too long, so I'll try to not ramble. And yeah, I will hopefully see you all next week. I would be surprised if there's anything that stops the stream, but you never know. And yeah. Until then, good luck with everything you're doing, and enjoy the rest of your day.